Dear students, welcome to my channel EEC. I am Dr. P. Suresh. In today's video lesson, we are going to discuss regarding bus impedance matrix. So in this video, we are going to learn what is bus impedance matrix, what is the use of bus impedance matrix, what are the methods by which we can construct the bus impedance matrix, and we'll solve a numerical problem using bus building method. So before constructing the bus building method, before going to constructing a bus impedance matrix, we'll see what is bus impedance. The bus impedance matrix, it is often called as Z bus. So Z is impedance. So Z is represented by Z, that is represented by impedance. It is a critical mathematical model used in power system analysis. It is essential for the power system analysis purpose. So it directly relates the current injected at various buses. So if you take any power system, the power system is consisting of buses, number of buses, and also all the buses are connected with the branches, or we can call as elements, the transmission line. So to the resulting bus voltages, we can identify the bus voltages. It is primarily placed for short circuit analysis or fault analysis. So whenever a fault occurs in a power system, we have to calculate what is the short circuit current or fault current. So for finding out or for determining a short circuit current or fault current, this Z bus matrix, bus impedance matrix, is essential. But also it is essential for transient stability analysis also. Transient stability analysis, and then it is important for relay coordination, and also it is essential for short circuit analysis. So whenever a symmetrical fault occurs, how we can find the fault current, and also when unsymmetrical fault occurs, how we can find the current. So for both the cases, symmetrical fault analysis and unsymmetrical fault analysis or short circuit analysis, bus impedance matrix is essential. So we have different methods by which we can construct the bus impedance matrix. So first method is early factorization method. Second method is matrix inversion. So for matrix inversion, we are going to invert the matrix for finding the Z bus. So before inverting or before finding the Z bus matrix, bus admittance matrix is essential, because we know bus admittance is represented by Y. Okay, so when with the help of bus admittance Y value, we can easily identify, we can easily construct bus impedance Z bus matrix, because we know that impedance is the inverse of admittance, Z equal to 1 by Y. So initially, if you know what is Y matrix, we can find Z matrix by inversion. That is the second method. And the third method is called as bus building method. So in this method, we are going to build the buses one by one. Right. So building the buses is done with the help of the elements. So if we take a power system, the power system is consisting of n number of buses. So the buses are connected with the impedances, okay, or elements, we can call as elements. So using the impedances which is connected between the buses, we can construct the bus impedance matrix. Okay, so that is the third method. So among the three methods, we are going to solve a problem using a bus building method. So third method. So for finding the bus building method, for using bus building method, I will be taking a example problem here. So the problem is given. For the power system shown in the diagram, form the bus impedance matrix. We are going to form bus impedance matrix, that is Z matrix, by using bus building algorithm or bus building method. So this is the power system given to you. As you know that the power system is consisting of number of buses. So here we consider three buses. Buses are 1, 2 and 3. And also, as I told you earlier, that the buses are connected with the transmission line. The transmission line is having parameters, line parameters. So those parameters, it is represented as Z here. So this value J.4 is nothing but it is the impedance value which is connected between bus number 1 and 3. And similarly J.2 here and J.2 here. So all these are called as impedances. So in a power system, the transmission line parameters are given in terms of impedances. And also the value of impedances are in terms of per unit. All the values are per unit. So J.4 is per unit, J.2 is per unit, again J.2 is per unit, right? So for this given power system, we are going to form Z bus matrix. So Z bus matrix. So as this is going to be a matrix, the matrix is going to be having some rows and columns. It's a matrix, so it's going to be a matrix. So this will be having rows and columns. All the vertical elements are called as columns, all the horizontal elements are called as rows. So rows and columns. So if you take the matrix will be having some elements. So how many elements are here? So that is nothing but the size of the matrix, right? So for the power system, we are going to construct the bus impedance matrix, that is going to be a final matrix. Then what is the size of the matrix? So for finding the size of the matrix, we have to consider the number of buses. So normally the size of the matrix is going to depend upon number of buses. So here we can see there are 3 buses, bus number 1, bus number 2, bus number 3. There are 3 buses. But among the 3 buses, we are going to consider one of the buses as the reference bus. So here bus number 2 is considered as reference bus. Then we have to omit the bus. So leaving that bus, we have 2 buses. Then if you are going to form or construct a bus impedance matrix, then the size of the matrix will be 2 by 2. So it will be having 4 elements, 1, 2, 3 and 4. So this is the size of the matrix, right? But also, as we know that the transmission line, it is going to be connected between buses. So bus number 1 and bus number 3, if you take this J.4 impedance, that is connected between bus number 1 and 3. So here the bus number 1 is called as start bus, and bus number 3 is called as end bus. Okay, and similarly if you take this one J.2, then start bus is first bus number 1, end bus is bus number 2. And similarly for this case, for this point 2, starting bus is 3 and end bus is 2. So in order to generalize this one, I will be taking those values as start bus as J and end bus as K, JK. Okay, so this is nothing but J and K, JK. So J is 2, K is 2, so 2 by 2 matrix. So if you take the elements here, so I will be taking J here and K here, J here and K here. Actually JK is representing the bus numbers. Okay, so we are going to construct the bus impedance matrix, right? So how the bus building method is used here? Actually, using bus building method, we are going to build the buses one by one. So after building a bus, a particular bus, we have to determine the bus impedance. So using the bus impedance matrix, we are going to build, or we are going to connect another bus. Now after connecting the another bus, second bus, we are going to identify what is the matrix. And similarly, we are going to join the third bus. After connecting the third bus, we are going to identify, we are going to find the impedance matrix. So each and every addition of element, each and every addition of bus, we are going to form the bus impedance matrix. So it is going to be a step-by-step method. So for each and every step, I am going to join an element, or I am going to add a bus. Okay. So for this case, I am going to use the step-by-step method for finding the Z bus matrix. And as we know that the size of the matrix is 2 by 2 here. So strictly there are 2 buses. But once the Z bus is constructed, so the final size of the matrix will be 3 by 3. So after that, we are going to reduce one of the buses, or we are going to eliminate the buses. So after elimination, we will be finding the final bus, or final bus impedance matrix. Okay. So the elimination is to be carried out by Cron's method. You know that by Cron's method, we are going to eliminate one of the buses, and finally we are going to arrive the construction of bus using bus building method. The size of the matrix comes around 2 by 2. So for this, I will be taking step number 1. I am going to consider step number 1. For the step number 1, I am going to consider only the first bus. You can see here, this is the power system given to you. The first bus is connected between reference bus and then bus number 1. So I will be taking only this element that is going to be connecting bus number 1 and 2. So this element only. So if I consider that one, you can see here, this is reference bus. So this is going to be a reference bus, and this is bus number 1. So these two buses are connected with the element j.2. So only for this bus I am going to construct Z bus. So Z bus is equal to, as we know that the size of the matrix is number of buses leaving reference bus. So leaving the reference bus, we have only one bus, then the size of the matrix will be 1 by 1. So the size of the matrix will be 1 cross 1. So this is the size. Only one element should be available, right? So for this case we have rows and columns. So for rows and columns, as we know that the bus number will come. So bus number 1 will come here, bus number 1 will come here, because we are considering only one bus, right? So what is the value of the element here? So this element is nothing but what is the impedance value given here. So that you have to write it here. So it is J0.2. Now this is nothing but your impedance matrix. So J0.2, it is the impedance matrix when only one bus is connected, right? Now we are going to join another bus, because you can see here bus number 2 and bus number 1 is over. Now I am going to join bus number 3 using the element J.4. So for that I am going for step number 2. So step number 2. For step number 2, what I am going to do? I am going to add one more bus. So once another bus is added, you can see here this is already completed. So now this bus 1 and 3 is connected. Now for this case I am going to construct Z bus matrix. So Z bus. So what is the size of the matrix? You can see there are 3 buses. One of the buses should be considered as reference bus. Number 2 is considered as reference bus. So leaving that we have 2 buses. Then the size of the matrix will be 2 by 2. So you can see here this is the size of the matrix. So you can see this is size of the matrix. So what are the buses considered here? So the buses considered are bus number 1 and bus number 3. This is row wise, and column wise again bus number 1 and bus number 3. So this is 2 by 2 matrix. This element is 2 by 2. So we have 4 elements, 1, 2 and 3, 4. Okay, so these are all the elements that should be filled here. So how the elements should be filled? So these elements should be filled with the help of previous matrix. So this is the previous matrix. Okay, so this is the previous matrix. Using this previous matrix we are going to fill the elements. So how it is filled? So if you take this one, this is related to bus number 1 and bus number 1. So because J.2 is connected with the bus number 1, so it is related to bus number 1. So write the value here, simply write the value here, J.2, right? And you have to fill this value, you have to fill this value, you have to fill this value. So for filling this value, just write the value, previous value, it is J.2. So this column, the column value should be coming here, and the same is nothing but the row. So same row should be written here. Okay, so these are the elements. But what about this one? So this element should be filled using the previous or latest diagonal element added with the new branch connected. So what is the new branch connected? It is J.4. So this is added with the latest diagonal element. So latest diagonal element is J.2. So we are going to add that one. So it is J0.2 plus J0.4. Okay, so this is the matrix. So you can see here. So this is bus number 1, this is bus number 3, and this is bus number 1 and 3. Then the value will be J0.2. So here it is also J0.2. It is also J0.2. Here it is J0.6. So this is going to be a 2 by 2 matrix. Okay, so this is how we construct the new matrix with the help of the old matrix. So this is step number 2. So the buses, reference bus is connected with bus number 1, one is connected with bus number 3, and the third one is third step, bus number 3 is connected to reference. So we are going for step number 3. So this is your step number 3. So step number 3 is connecting all the buses. So for this case I am going to find Z bus. So how many buses are here? There are 3 buses. Okay, now strictly there are 3 buses. then the size of the matrix will be 3 by 3. So I am going to construct the bus system. So this is going to be 3 bus system like this. So what are the buses connected? Bus number 1, bus number 3 and bus number 2, that is reference. So here it is also bus number 1, 2 and then 3. So this is going to be a 3 by 3 matrix, 3 by 3 matrix, right. Now I am going to fill the elements. So here we have to fill 9 elements. Out of 9 elements, I am going to fill 4 elements from the previous matrix. Okay, so what is the previous matrix? Already we found from the step number 2. This is from step number 2. From step number 2, we have identified Z bus as this one. So simply write the value here. Okay, so fill the value. It is J0.2. It is J0.3. Sorry, J0.2. So here it is also J0.2. So here it is J0.6. Okay, 0.6. So all the values are written. But also these elements, we have to fill. So the third row, these two values should be taken from the previous column. Okay, so simply write the values here. J0.2. These value, these two values should be written here. So this is going to be, this column should be written here. Similarly, the latest row should be written here. So J0.2. So here it is also J0.6. Right. Now we are going to fill this one, ninth component, ninth element. So ninth element is nothing but taking the previous latest diagonal element added with the new branch connected. So you just write the value here, it is J0.6 plus the latest value, it is J0.2. J0.2. Okay. So now we can see here there are 9 elements. So this is going to be a 3 by 3 matrix. Right. So we can see here, this is the matrix we found. Now, as I told you earlier, for the given bus system, as we have 3 buses, one of the buses should be taken as reference bus. So for this case, we took second bus as the reference bus. So leaving that, we have only 2 buses, but we arrived with the matrix size as 3 by 3. So one row and one column should be eliminated, so that we can identify, we can find 2 by 2 matrix. So which row, which column should be eliminated? So see here, reference is bus number 2. So this column and this row should be eliminated. So elimination is nothing but, it is not going to be simply removing the values, but after removing the matrix, after removing the row and column, we are going to modify the matrix. After modification, we are going to have a 2 by 2 matrix. Okay, right. So how it is formed? So in order to modify the matrix, so what is the modification of matrix? Eliminating a row and column. Okay, so that is done by Cron's method. So using this method, we are going to eliminate the row and column. So for this case, this is the derived matrix. Okay, latest matrix we derived, this is going to be a 3 by 3 matrix. Okay, so from use of this matrix, using this matrix, we are going to modify the matrix, but we have to use the formula Cron's method. So in order to use the Cron's method, the formula for eliminating row and column, that is given by ZJK new, because we are going to form a new matrix, because this is the old matrix given to you, 3 by 3 matrix, but we are going to form a 2 by 2 matrix, that is a new matrix. But the new matrix, it is derived by or taken from old matrix. So is it JK, old minus, it is Z NK dot JK JK dot Z NK divided by Z NN. So this is the formula. zjk equal to zjk new equal to zjk old minus zjk minus znk by znn. So using this formula we are going to, so this is the formula for Cron's method. So here we are going to find a new matrix, okay, jk new. So we are going to use old matrix, jk old minus zjn into znk by znn. So here what is n? So n is nothing but which row and which column should be eliminated. So from this matrix the third row and third column should be eliminated. So here n equal to 3, right? What is j and k? So j is nothing but the bus numbers. Bus number is 1 and 2 because we are going to construct 2 by 2 matrix. So j value will be 1 comma 2 and the k value will be 1 comma 2. Okay, right. Now we are going to form the matrix. So this is row and column. So the row and column you can see here, the elements will be in a matrix like in a 2 by 2 matrix. The elements will be 1 1 1 2 2 1 and 2 2. Okay, so first I will take the first element. Okay, the first element will be z1 1 because I am going to consider first as j equal to 1 and k equal to 1. If you substitute the value j and k value and n value in the previous formula, I will be getting z11 new is equal to same way z11 because jk is here, so jk it is 11 minus z, what is j? It is again 1, what is n? It is 3 multiplied by z, n is 3 and k equal to 1 because we are considering, we are taking only jk as 1 1 only, okay, that is why. So divided by znn is z33. So all these values z11 z13 z31, these are elements which we already derived here, which already formed. So from these we are going to make this one. So substitute the values. What is z11? Z11 is here, so here this is z11, so it is j0.2 minus z13. Z13 is again you can see here z13, so this is z13 j.2, so it is j0.2 multiplied by j31, again it is also j.2 by z33. Z33 is, so here it is j0.8, it is j0.8. okay, don't take this is 3. okay, so first column, this is first column, second column and third column. Okay, we are going to eliminate third column, so n equal to 3. That is how we have to take. Don't consider bus number here. Okay, so if you use the calculator and if you change the calculator into complex mode and if you find the answer, then it comes around j0.15. Now if you take the matrix 2 by 2 matrix, first element is identified, right? Now we are going to identify second element. For this case we have to consider j is equal to 1, k equal to 2, j equal to 2. So what is the value? If you substitute j equal to 1, k equal to 2, then this becomes z12, again new is equal to, substitute the value z12 minus z, what is j value? J value is 1 and then k value here it is 2 multiplied by z21 divided by z33. Okay, so substitute the value. What is z12? Z12 is here, z12 is here, so it is j0.2. so again it is j0.2 minus j0.2 into 200 is j0.6 divided by it is j0.8. So if you find the value, it is j0.05. And similarly, when you identify z12, that is same as that of z21. And the third case, so 1 1 is over, 1 2 is over, 2 1 is over. Now we are going to find z22. So z22 new is equal to Z22 volt minus the value is Z23 into Z32 divided by it is 23 by Z33. So which is equal to J 0.6 minus J 0.6 into J 0.6 divided by J 0.8. So the value it is coming around J 0.15. Right. So this is the third one. Right. Now the final matrix is nothing but Z bus, which is equal to rating all the values. So it is J 0.15. So it is J 0.15. So here it is J 0.5. So 0.05. So this value is also J 0.05. So this value is J 0.15. Okay. So this is the final matrix. It is a 2x2 matrix. So this is how we can eliminate, one of the rows and columns using Cron's methodology. So for the given power system, so this is the Z bus matrix. So this is the way by which we can build the matrix one by one, and finally we can reach the answer. Thank you, students.